Hello. It's Mr. Lawrence here, and we're going to solve systems by elimination again. These will be a little bit more involved. There'll be a few more steps to them, and it's likely we're going to get some uglier answers, kind of like we did in some of those substitution problems. But it's important to know how to do this, like I said, so you can choose what would be the most effective way to solve a system. All right, let's get right down to it. Oh, by the way, I've got my calculator standing by, so you know the answers are going to be a little bit strange. Okay, very likely anyway, I can't guarantee it. Okay, now notice how in equations, in the first two problems, the first system, neither of the coefficients match. On the y's, I have opposite signs, but they're not multiples of each other. In a situation like this, I'm going to have to multiply both equations by a number. I'll decide if I want to get rid of the x's or get rid of the y's, and then I'll have to multiply the equations so that I can make the coefficients match with opposite signs. I think in this situation, I want to get rid of the y's. I think that looks pretty easy. So I'm going to multiply the top equation by 4, but I'm going to multiply the bottom equation by 3. How did I know that? Well, I found the least common multiple of 4 and 3. It's 12. So that's what I decided to do. So my top equation will transform into 8x plus 12y equals 24. And then when I multiply the second equation, I'm going to get a 9x minus 12y, and that is going to equal 36. Now I'm going to add those two equations together. My y's will cancel. I'll be left with 17x, and I will have 60. And I don't believe 17 goes into 60 evenly. Okay, and here's where I'll go decimal. Um, that's probably going to be a rounded answer. So let me do 60 divided by 17. And there we go. I get a real ugly answer. I'm going to caution you to not round it too soon. You can go to the hundredths place, um, but watch what I'm going to do. I'm going to round it to the hundredths place, but I'm not going to clear my calculator. I'm going to keep that number in there because I'm going to use it in my calculations. Okay, so now to figure out why, I can pick any of the four equations. Um, hold on, I lost my highlighter. There's this one here before I multiplied, and there's this one here before I multiplied. There are also the equations after I multiplied. Any one of those four work, whichever one you think is the easiest. I think I'm going to go ahead and go with this one, and I know I'm going to get 2. I do that often, don't I? All right, 2 times the 3 and 53 hundredths plus 3y is going to equal 6. Now I know I'm going to subtract this value. So when I do, I'm going to get 3y, and that's going to equal something. Well, here, watch what I'm going to do on my calculator. I'm going to go times, oops, that's not going to work. I'm going to press times, get rid of that ink spot, times 2. I just multiplied that big ugly decimal by 2. Now, I've got to take that away from 6. So I'm going to go 6 minus, I'm going to hit my second key, and then down here is an ANS, which stands for answer. This means 6 minus 7.0588823.529. All right, so I'm going to get that 3y is going to equal negative 1 point. All right, so 3y is going to end up, let me show you what I did here. I I subtracted this number from both sides. Okay, and when I do that, I get 3y, and it equals 6 minus this. I'm letting the calculator do the actual work. I'm just showing it with 3 and 53 hundredths because I'm after precision here. So I get this 3y. Okay, so now that equals this number. So I'm going to have 3y. It's going to equal negative 1.0588. And again, I'm rounding it in my answer, but not in my calculations. So now I'm going to divide by 3. And so y is going to equal, and see, I just go right here and I hit divided by, sorry, you can't see what I'm doing, by 3, and it's taking that negative 1.058823 number and dividing by 3. And now I have negative 0.3529, and here is where I'll provide a rounded answer. So it'll be negative 0.35. So these cross at approximately 3 and 53 hundredths and negative 0.35. Okay, let me rewrite that. There we go. Okay, so the answers have potential to get a little bit uglier. All right, let's look at problem number 2, a similar situation. I think on problem 2, though, I'm going to be looking to get rid of the x's. I like working with 5 and 4 more than I do negative 6 and positive 7. So I think I'm going to multiply the top equation through by 4. I'm going to multiply that bottom equation through by negative 5. That'll make both of my coefficients on x 20, although one will be positive and one will be negative. So I'm going to get 20x minus 24y, and that's going to equal 120. And then I'm going to get negative 20x minus 35y, and that is going to equal 70, right? Negative 70? Okay, now I'm ready to add the two equations together. When I do so, those cancel. It looks like I'm going to get a negative 59y, and that's going to equal 50. And I'm going to divide by negative 59, and divide by negative 59, and y is going to end up equaling a negative, and I'm going to go to calculate. I could put 50 59ths. That is an ugly fraction to work with. So I'm going to do 50 divided by negative 59, and I get that decimal there. And again, I'm not going to clear my calculator. I'm going to go ahead and use that 8, 4, well, probably 8.5 if I round properly. Okay. I'm not going to use the 0.85 in my calculations. I'm going to use this because with the graphing calculators or the TI 30X2S's that you guys have, there's no reason to do it. All right, I think I'm going to plug that into the second equation. Oh, excuse me, into the first equation. And so I'm going to get 5x, and that's going to be plus 6 times this negative 0.85, and that's going to need to equal 30. And so I'm going to have 5x, and this is going to end up being what number? I guess I got to multiply it by 6, so I'll go times 6, and I'm going to get a very similar number, negative 5.085, so negative 5.085, and that's going to equal 30, right? add that to both sides. Oh, sorry. And I will end up with 5x equaling this 35.085. And then I'm going to have to divide it by 5, right? So let's see here. Now you see, if I divide this number here, this rounded number by 5, it's going to come out to a decimal that stops. But um, my other one will stop, but it's just not going to be as pretty. All right, I'm going to multiply this number by -1 to make it positive, and then I'm going to add it to 30, and then I'm going to divide by 5, and I get that ugly decimal. And when I do that, I can go ahead around then. I'm going to say 7.02, rounding to the nearest hundredth. Okay, it's just being more precise. Some other teachers may not say do it. I really like precision as much as possible. When people aren't precise, they make mistakes. Okay, and lead to inaccuracies in their mathematics, and that can matter if you're an engineer or something like that. I'm not making you do the precision. I'm saying let the calculator do the precision for you. And then you can give me a slightly rounded answer. All right, that's it. Just a couple examples. Mr. Lawrence signing off. Have a good night, everybody.